Good morning, good afternoon, good evening, everyone. Thank you for crunching out time from your schedules to make up to this session. A very warm welcome to each one of you. I'm Priyanka, Senior Mainframe Architect at Royal Cyber, and I'll be the host for today's session. I'm joined by Ganeshwar, who is our Mainframe Practice Lead. Today, we will dive you in how artificial intelligence and machine learning are revolutionizing the mainframe modernization landscape. We do have some great demos lined up. So before we get started, let us take a moment to introduce Royal Cyber. With an expertise of over 2 decades in technology, IT consulting, and digital transformation, Royal Cyber is uniquely positioned to provide businesses with transformative and innovative solutions that sets industry standards. As IBM Primer partner, we have launched successfully innovative products and established partnership with MuleSoft, Microsoft, AWS, GCP, Salesforce, ServiceNow, and many more, driving towards achieving the business results with elevated customer experiences on the transformation and modernization journey. Here is the agenda that we have outlined that is tailor fit to sail you through the real world challenges and why we need to modernize, all the way with the concept and models that are derived from the machine learning and artificial intelligence, how it is infused in the mainframe ecosystem with some AI and ML products, a toolkit for IBM Z and Linux one with some real time use cases on artificial intelligence and machine learning, a brief demonstration on Operational Decision Manager and WatsonX, followed by legacy mainframe modernization framework, how artificial intelligence and machine learning are reshaping this industry, and finally, some Royal Cyber offerings. So let's first discuss about the real world challenges and why we need to modernize any system. There is a study that has recently revealed that over 70% of companies relying on mainframes reported difficulties in scaling their systems to meet growing business demands. Additionally, maintaining these legacy systems can consume up to 60% of IT budgets that leave very limited resources and room for innovation. The rigidity of these systems also hinders agility, with the development cycles for updates or any new features often stretching into months that impact the ability to respond to the market changes. Here are some highlights that showcase the critical need we have for modernization to stay competitive in the today's digital landscape. The foremost is the legacy dependencies, in which many organizations rely on the decades old data and systems for their applications. We have a lack of real time data insights that needs to be aligned with the trends we have on the decision making and the preferences. A need of competitive edge to adapt faster to the market needs, bridging the skill gaps, real time data analytics capabilities, and finally scaling and innovations. So these are the parameters that depicts the critical need for us to modernize to scale with the system, improve customer experiences and operational efficiencies. So with ever increasing digital demands, application modernization is top of mind for many organizations, particularly which are with the mission critical applications like ZOS, So many US enterprises have large investments in applications that rely to run their businesses. After many years in existence and multiple changes, these apps can often be highly complex and tightly coupled with data and other applications, but are tested and critical to business. While modernization can take many forms, changing programming languages, implementation DevOps pipelines, implementing REST APIs, decision management also be valuable component of modernization strategy, which provides us the capability of enhanced agility that meets with the evolving business needs. It will lower the operational costs. It improves the system reliability and performance with the simplicity and ease of management, seamless integration with cloud and hybrid environments, accelerated innovation with AI-driven insights, with flexible deployment options, role-based permission management, built-in governance process, and many more. So there is a lot of buzz on artificial intelligence and machine learning. Let's find out exactly what this concept is basically. So artificial intelligence and machine learning are the transformative technologies that are reshaping industries, including the world of mainframe computing. These technologies enable systems to mimic human intelligence and improve over time without any explicit programming, making them ideal for modernizing legacy systems, even mainframes. So, when we talk about AI is a broader concept that encompasses machines designed to perform tasks that typically requiring human intelligence. The goal of artificial intelligence is to create systems that can reason, learn, adapt, and make decisions. AI can further classified in two broad types. We have narrow AI, which we call it as weak AI. This is designed to perform specific tasks like recommendation systems or voice assistants like Siri or Alexa. It is not self aware but can excel at a single function. Then we have general AI, which we call it as strong AI also. This is more theoretical at the moment and it aims to create machines that can perform any intellectual decisions or tasks that a human being can do, which exhibits the reasoning, learning, and decision making at human level. In the concept of mainframe modernization, narrow AI is the most relevant, with applications such as predictive analytics, intelligent automation, and decision support system. So let's talk about machine learning. So machine learning is basically a subset of artificial intelligence that focuses on the development of algorithms that enable systems to learn from data and improve over time without even explicit, explicitly programmed. A sense of machine learning is to identify patterns in data, make predictions, make informed decisions based on those patterns. So here we see that in the traditional systems, basically we fed data and programs into the system which derives the output. Now with the concept of machine learning, we feed in the data, the real time insights, the output we want to achieve out of it, and it is automatically programmed based on the different patterns that we and the models we have on the data. So we have different types of machine learning. We have supervised learning. In supervised learning, the model is trained on label data. Basically, when the output, which we call it as label, is known. So the goal of this model is to predict the correct label for new or any unseen data. This can fit in the systems wherein we need predictive analytics, performance based issues, the predictions on any historical data where it will identify and derive the performance parameters. We have unsupervised learning, and in this type of model, we have machine learning algorithms that are trained on data that works on without the labels. So the goal of this model is to identify the hidden patterns or grouping in the data. This is fit for the systems that need some behavioral pattern without any predefined labels or outcomes. Then we have reinforced learning. This is a type of learning wherein we need to involve an agent that interacts with the environment, which takes actions and learning from those results. It's often used for the making in the or the automated decision making in the dynamic environments. Then we have a subset of semi supervised and self supervised learning. So these are the hybrid approaches wherein the models will use both labeled and unlabeled data. This is fit for improving the systems from anomaly detection with limited label data by leveraging the structure of patterns itself. So here we have different artificial and machine learning products wherein we have Python AI tooling set which access a library of relevant open source softwares to support AI and machine learning workloads. We have Accelerate TensorFlow interface. These are the models that are trained anywhere and deploy close to the business critical applications on IBM Z by using IBM integrated accelerators for artificial intelligence. We have in-memory computing performances that move forward with in-memory compute engine and analytics that run on the big data languages such as Java, TM, Scale, Python, and R. We have compiled compatibility AI models into ONX format and run on IBM Z with minimal dependencies by using IBM integrated accelerators for AI seamlessly. So here is a brief plethora of the AI toolkit. So the concept of artificial intelligence and machine learning are based on the key concept of the models that are inspired by human brain, consisting of layers of nodes, neurons that work together to process data. Deep learning is one of the neural network that has gained popularity in the recent years due to its capability to process large and complex data sets. We have natural language processors. This is a subset of artificial intelligence that focuses on the interaction between the computer and human language. It enables systems to understand, interpret, and generate human languages. For example, analyzing any unstructured data such as logs or help desk tickets in mainframe systems to automatically classify and route issues. We have model training and testing, which is a model that is trained using the historical data, then testing on a new data to ensure it generalize well and make accurate predictions.